Continue with the differentiation of inverse of trigonometric function, but we have dealt with the differentiation of this. The differentiation of this one can be obtained using the same procedure as this. Actually, the differentiation of cos is the differentiation of cos will be given to you later. But the differentiation of the inverse of tan, let's approach it the way we have just approached the sine, inverse of sine. Then we can just say let y equals to the inverse of sine. You have made y the variable that you introduce now. Following the same procedure, multiply both sides by tan. That's tan y is equals to arc tan, or the inverse of tan. Multiply both sides by tan. Then this is tan y is now equals to, this can be expressed as the inverse of tan, which is written like this, multiplied by tan. So tan cancel out tan here. That implies that my s is equals to what? Tan y. My s is equals to tan y here. Then we can say from here we can find the x dy, the s dy, and that will be what? When you differentiate tan, it's going to give us sec square y. We have dealt with this initially, but we are expected to find the y ds, not the s dy. Then we take the inverse, that's the y, the s is equals to 1 over sec square y. This is where we have. This is the answer we are looking for, yes. But this y is an introduced variable. Then we have to get rid of this y. How do we get rid of this y? There's a combination, there's a relation relating sec and tan together. That is 1 plus tan square y is going to give us sec square y from our trigonometry ratio, if you remember that. So sec square y can be replaced with 1 plus tan square y. So that means you can have about sec square y to be equals to what? 1 plus tan square y. Then we can introduce this here by saying our dy, the x, is now equal to 1 over 1 plus tan square y. And this can be further broken down. We are given tan s equals to tan y, and that can be 1 over 1 plus s squared. Tan y is x, so tan square y is going to be equals to what? S squared. Then finally the y, the s, is going to give us 1 plus s squared. So the derivative of the inverse of tan is going to give us 1 over 1 plus s squared. That's for tan. Then for cos, we can obtain it equally. We can obtain the cos equally when you have to find the x of the inverse of cos square x. When you obtain that equally, what you will get is minus 1 all over square root of 1 minus s squared. Square root of 1 minus s squared minus 1. You can go through this using the same procedure, and this is the derivative of the inverse of cos.